Hi, Algebra 1. Today we are going to start studying Chapter 10 in our books. That'll be page 600 is where we are. And we will be dealing with a lot of radicals, square roots, and radical equations in this chapter. The obvious place to start, though, is to talk about right triangles in the Pythagorean theorem. And so I want to remind you of some geometry that you already have learned, and that is this situation of the Pythagorean theorem. There's a special relationship between the three sides of a right triangle. And when I say right triangle, it means there is a right angle involved in that triangle. We know that means it has a 90-degree angle. We show that in pictures by putting a little square inside the right angle. So whenever I have a right triangle, my drawing is terrible, but it doesn't matter because you can get what you need from the picture knowing that this says it's a right triangle. And when I have a right triangle, I have one side that's called the hypotenuse. And that is always, there's two characteristics that define a hypotenuse. It is always the side that is across from the right angle. And it's always the longest side of a right triangle. We refer to the other two sides adjacent to the right angle. We call those legs. So we have two legs and one hypotenuse. Well, there's a relationship in those lengths, and we know that my a squared, one leg squared, plus the other leg squared equals my hypotenuse squared. We simplify that and we say the Pythagorean theorem says a squared plus b squared equals c squared, knowing that c is always the hypotenuse. It is always the longest side of a triangle. So we're going to do some practice problems today that just apply the Pythagorean theorem and also just get us comfortable with working with how to solve equations that have squares and square roots in them. Okay, so the first problem that you see is problem number 1. And you're given this picture. I have a right triangle in this picture. And the question just simply asks, what is the length of the hypotenuse? Well, remember what I said. The hypotenuse is the longest side, and it's across from my right angle. So if there's ever any question when you're looking at a picture, which one's the hypotenuse, which one's the leg, which one's shorter, the longest side is always across from the right angle, and that's always my C in my Pythagorean theorem. So in this case, I have 6 inches on one side, 6 inches on the other. So we have an isosceles right triangle. And I can use my Pythagorean theorem. I know to set it up. I know these two are my two legs. They're my shorter sides. So if I plug that in, it's 6 squared plus 6 squared equals c squared. That's my unknown side. Well, if I were to just say simply that c is 12, not only would that be completely wrong, if you're just looking, well, it's 6 plus 6, since all of these are squared, c would have to be 12. It is completely wrong because it's also using our order of operations incorrectly. As you know, we have to deal with exponents first before we do any adding and subtracting, multiplying, or dividing. So I need to go through and actually figure out what those numbers are. So 6 squared is 36 plus 36 equals c squared. Well, c squared, the c is my unknown, so that's going to be the last thing that I deal with. But I have to first raise each of these to the second power, do the math, and then find c. So now I'm going to add those. And 36 plus 36 is 72 equals c squared. Well, how do I figure out what c is if I know what c squared is? Well, if I just want c from c squared, I take the square root of it. And remember, it's a little sloppy, I can do anything that I want to an equation as long as I do to both sides. So if I'm going to take the square root of c squared, I need to take the square root of 72. And we call this the principal root of 72 Because as we know from our previous experience, a square root can have a positive or a negative answer. For example, the square root of 9 could be 3 or negative 3, because negative 3 squared is also 9. But whenever we want the measurement of a side of a triangle, we want the principal root or the positive version. Because obviously we're talking about a measurement, we wouldn't want a negative number. We would want only the positive one. So once I do this, I figure out that square root of 72 is C. At this point in the game, we will be dealing with radicals a little bit more as we move through this chapter. But I think the problem, let me get there. Oh, I'm not even on the right page. Page 600. I believe the question says find it to the nearest. Nope, it doesn't tell me to, but you can use your calculator. When I want to know what the square root of 72 is, I can use my calculator, and you're going to want to have your calculator handy for a lot of these problems. I get that it's approximately 8.5. And we've learned what that symbol means, approximately. It's 8.5 something, something, something forever, because it's not a perfect square, but we would round it just to the tenths. 8.5 is approximately the length of side C. Okay, I want you to try one of these on your own. I'm going to leave up the Pythagorean theorem. I'm going to change the dimensions of this triangle. And your practice problem is the got it problem under problem 1. And this time it's saying, what is the length of the hypotenuse of a right triangle with legs of 9 centimeters and 12 centimeters? I didn't change my picture at all, but that's okay. You can still see that we're dealing with a right triangle. My unknown side is my hypotenuse, but now I have 2 different measurements to deal with. I want you to pause the video and try using the Pythagorean theorem to find the measure of side C. Go ahead and pause it and come back when you're ready to go over it. I'm going to use these numbers. I know that they are on either side of my right angle, so they're my legs. They're my shortest sides. So I'm going to plug it in as 9 squared plus 12 squared equals C squared. And if you just said 21 is your answer, you're completely wrong. You're not using your order of operations, and you didn't listen very carefully to our example problem. I need to actually find out what each of these numbers is squared, then do the math to solve for C, because exponents come first in my order of operations in this problem. Okay, so 9 squared is 81. 12 squared is 144. And you're going to find yourself getting a lot faster of some of our more common squares that we will be dealing with. And when I add those together, let's see, I have 81 plus 144 gives me 225. And that equals C squared. Well, and if I want to find C, I have to take the square root of both sides. And this is one that you're going to get very comfortable with. 225 is actually a perfect square. And if you didn't recognize it, that's where the calculator comes in. The square root of 225 is 15. So the measure of the hypotenuse in this problem is 15. Okay, I'm going to clear the board again. And we will be doing 2 problems. Instead of finding the hypotenuse for the next set, we are going to be finding one of the missing legs. Now, I erased the Pythagorean theorem from the board so that we have plenty of room for our problems. You should, if you don't already have it memorized, you need to work on memorizing the Pythagorean theorem. Let's see. I'll get both of these pictures on here together. Save us a little time. Okay, so for problem number 2, I have this situation. I have a right triangle. I know that it's a right triangle because of this symbol in that angle. I have one leg, two legs, and a hypotenuse. Hypotenuse is the longest side across from my right angle. I know the Pythagorean theorem tells me a squared plus b squared equals c squared. So I'm going to take those given values and plug them into my equation, and you'll see there's a little bit different process here because we're not finding the hypotenuse this time. 5 squared plus b squared equals 13 squared. This time, this is the missing information I'm trying to find. Well, the same thing applies. Exponents have to come first. So I need to figure out what 5 squared is and 13 squared, and you should be getting, well, some of these you definitely should know. 13 squared is 169. If you didn't know that, that's what your calculator's for. Now I need to solve. I want to get my b squared alone, so I'm going to subtract 25 from both sides. And I get b squared equals 144. And again, because I'm talking about an actual measurement of a side of a triangle, I don't want the negative value here. I want the principal root, or the positive version. 144 is a common perfect square, and so that tells me if I take the square root of both sides, I get b equals 12. Okay, I want you to pause the video and find side A in this right triangle, and you can restart the video when you're ready to go over it together. Okay, my hypotenuse is my 15. It's across from my right angle, and I know that it's the longest side. So I'm going to take these values and plug it into my equation. A squared plus 12 squared equals 15 squared. And again, like I said, you're going to get a lot of practice here with your perfect squares. If I simplify this, I get a squared plus 144 equals 225. And if you're thinking these numbers sound very familiar, you are right. This is a common Pythagorean triple, and we just saw this actually in our first practice problem we did together. But let's keep going with the math. If I want to solve for a squared, that means I need to subtract 144 from both sides. I get a squared equals 81. If I need to find what a is, I take the square root. If I take the square root of one side, I have to take the square root of the other. And 81 is a perfect square. And so I just found that a equals 9. Again, taking the principal root of the problem. Okay, there's one other type of problem that I want you to be comfortable with, and I already wrote this one out. It's in your note handout. It's also problem 3 in this section. And if I give you the measurements of 3 sides of a triangle, you can use your logic and your understanding of the Pythagorean theorem to work backwards through and confirm whether this is a right triangle or not. It can be a triangle, but we want a specific type, and that's the right triangle. And we already said that the Pythagorean theorem applies to only right triangles. So if my 3 measurements fall into that equation and make it true, I can use my logic, and you guys are all in logic class, so the converse is also true. That means if it satisfies the equation, that means I had a right triangle. So I just wrote down the numbers on your note handout and in the book. They had the units with it. We had inches in this first example, meters, inches, and feet. I just took the numbers though for the sake of space. If these are the measurements of 3 sides of a triangle, I need to use them and plug it into the Pythagorean theorem. And again, if it makes a true statement, that means it is indeed a right triangle. So what I'm going to do next to each one of them is just quickly take these values and plug them in to my equation. They're written in a nice order for me though. You can see it goes from least to greatest, knowing that my greatest number is always my hypotenuse. That's the C in my Pythagorean equation. So that means I have 6 squared plus 24 squared equals 25 squared. I'm going to go through and set up the equations for all of these first. 4 squared plus 8 squared equals 10 squared. 10 squared plus 24 squared equals 26 squared. And my last one, 8 squared plus 15 squared equals 16 squared. Now at this point, I don't expect you to know what all of these squares are, so you need to use your calculator if you don't. But as I've said so many times, you're going to start getting good at these. Okay, now I've already done some of this math, so I will plug it in for you. Okay, 6 squared is 36. 24 squared is 576. And it equals 625. Now I know I'm really squeezing in here, so you might need to zoom in on the video. If I were to add 36 and 576, unfortunately, I wouldn't get 625. So that is a false statement. Those two numbers do not equal, which means this is not a right triangle. Let's move on to the second one. 4 squared plus 8 squared equals 10 squared. Well, that's 16 plus 64 equals 100. Well, I know that 16 plus 64 equals 80, not 100. Not a true statement. That tells me that is not a right triangle. It can be a triangle. It's just not a right triangle. Okay, moving on to my third one. 10 squared is 100. 24 squared is 576. 26 squared is 676. Well, if I check this math, 100 plus 576 does equal 676. So we have one right triangle. Let's do our last one. 8 squared is 64, and now I realize we're getting to the bottom of the board. 15 squared is 225, and 16 squared is 256. If I add those together, they do not equal 256. Also eliminating that fourth one as an option. So while all of these could have been triangles, only one is actually a right triangle. And we confirmed that by plugging in the measurements into the Pythagorean theorem. Okay, so your practice problem, I'm going to go ahead and clear this board. Your practice problem takes this skill and just asks one version of this question. I'm going to give you the dimensions of a triangle. You need to tell me if it is a right triangle. Okay, so we have a 20, 47, 52. If those are the three sides, the measurements of the three sides of a triangle, you can tell me, yes, it is a right triangle, or no, it is not a right triangle. I want you to pause the video, use the Pythagorean theorem, and tell me yes or no. Come back when you're ready to talk about it. Okay, if you are finished with that by plugging it into the Pythagorean theorem, you should have gotten the answer no. These lengths do not satisfy the Pythagorean theorem. So it tells me that while this could be a very beautiful triangle, it is not a right triangle. I'll show you the work that is involved there. This is my biggest number, so it's my longest side. That's my C. 20 squared plus 47 squared equals 52 squared. If this is a true equation, it would tell me it is a right triangle. We know the answer is no, so let's see why that is true. Well, 20 squared is 400. You probably knew that one. 47 squared, though, is 2,209. It's a big one. You probably didn't know that one. I don't know that one either. I used my calculator for short. 52 squared is 2704. And if I add these two together, I get 2,609, not 2,704. Telling me not an equal equation, therefore it is not a right triangle. Okay, so you learned a few different ways to use the Pythagorean theorem in finding missing sides of a triangle or proving if a triangle is a right triangle or not. You have some suggested book problems written on the note handout as well as listed under RenWeb. And there are 2 Khan Academy assignments for today. They use all of the skills we just went over, and they will be due Friday at 5 p.m. Now, I know we don't have school on Friday. I'm just giving you an extra day to catch up with that work, and you can get it in by Friday at 5. Okay, have a great afternoon and a great long weekend, and enjoy your day off on Friday. Bye.